Now watch this question. This question is for direct mapping. Okay, so assume that direct mapping is used for the caching, and now this is the entire question given. There are actually 1 2 3 4 5 6 questions here. So they are given with some of the parameters, and some of the parameters are missing, and the assumption is that memory is byte addressable. So here we have to assume that the memory is byte addressable. Okay, what is the intention in specifying that is byte addressable is, if you watch it, the main memory size is given as KB, GB something, right? Therefore, when I convert this, or when I try to represent the physical address, that physical address is nothing but the number of addressable units in the main memory, right? So now when I convert this using this size of the main memory, if I try to find out the physical address, I'll take this 128k and convert it into number of bits. I'll find out the number of bits required to address 128k, right? In case if it is word addressable, and let us say word is 2 bytes, then you have to convert this into words first and then find out the physical address. See, so the main difference between word addressable, byte addressable, or saying that there are so many words in the memory and then each word is so and so is, first you take the address, the number of bits. If it is given, already address is given, then we have to take the address and find out 2 power that will represent the size of the main memory in terms of words, and then you multiply with the number of bytes per word. That is one thing. And the second thing is, whenever size of the main memory is given and a word is given as 4 bytes, convert the main memory size into words, and then you have to find out the physical address. Okay, I'll just take a small example and clear this point, and after that, the same concept can be applied to word addressable memories also. Okay, so see here, let us assume that the main memory size is 128 KB, right? And it is byte addressable. Byte addressable means every address you produce should be able to address all the bytes present in this, right? Now how many bytes are present in this? 128k bytes are present in this. Then how many bits are required in the address so that you will be able to address all the bytes uniquely? So it is 17, I think. Therefore 17 bits will be physical address. Physical address will be 17 bits. Now let us say it is word addressable. Okay, actually word definition itself is the smallest addressable unit is word. So saying word addressable is really not that meaningful, but then people are using it. So let us say it is word addressable, and then each word is 4 bytes. Then what is the physical address is, now the physical address should comprise of those many bits which should be uniquely able to identify every word. Then in this case, given the same main memory, physical address will change. See this. Now if the word is 4 bytes, then you have to find out how many words are here. So 128 kilobytes will now be equal to, I think, 32 kilo words, isn't it? Now these many words are there, and we should be able to address each word uniquely, not each byte uniquely. Therefore, what should be the physical address length? Physical address length should be 15 bits, right? So then only we'll be able to address each word uniquely, right? Here if we have to identify each word uniquely, it is 17 bits, and here it is 15 bits. Got it? So depending on what type of addressable system it is, the physical address length will change, right? So now since it is given as word addressable, our physical address should be able to generate those many addresses in such a way that each byte will be addressed uniquely. Got it? Okay, now let's get into the question. Now they are saying that main memory size is, see, don't worry about word addresses and byte addresses. With practice, by the end of this, all the memory units, either in OS or in this one, you will be able to figure out the difference, and it will be very simple. And most of the times they will just give you the bytes only, right? So that is why I'm taking bytes and I'm answering it. So they'll not really give you words. It is really madness to give you words and then ask you to solve the question, because no. Okay, fine. So let's leave it there. Now let's see this main memory. So main memory is containing 128 kilobytes, and cache size is 16 kilobytes and block size is 256 bytes, then tag bits and tag directory size is required. So which means they are given you everything and then they are asking you how many tag bits are required in the physical address. Tag bits in physical address. Okay, let us say this is tag bits in physical address, right? In the physical address, how many bits are used for tag, and then what is the tag directory size. Tag directory size means every line of the cache is going to have some tag bits. We have already seen it. Now all these tag bits added together, that will form the tag directory, right? Which means if you watch it, earlier we had 4 lines and each line had a this tag bits, this one, right? Now all these bits together, if you add them, that is going to become the tag directory. Sometimes what happens is, along with this tag bits inside the tag directory, for every line there can be something like valid bit, modified bit, just like the page table entries, right? And in case if you have more bits in the tag part of every line, then the tag directory size is going to increase, even though cache size is something, and along with the tag bits its actual size will be something. Okay, so whatever given here is without tag, and we are supposed to find out what is the tag directory size, which means now if I add this one with this one, I'll get the total size of the tag, total size of the cache. Okay, let's solve the questions first. Now main memory size is given as 128 KB. Okay, before solving it, this is the physical address. Okay, so why is physical address used? To address every unit or each element of the main memory. Now if the main memory is divided into blocks, then what happens is this physical address completely could be represented as two things now, right? Physical address can be represented as, one is this part be represented as block offset, which means in order to identify a word within a block we can use this number, and then the remaining part is nothing but the block number, right? This is how main memory views it. So according to main memory, right, it is block offset and it is block number, but according to the cache, how is it organized? This one is line offset, which means inside a line we are going to use it to find out the particular word, and then this particular thing is, some part of it is line number, right? And then the remaining part is going to be the tag. Got it? So now they are asking us to, they are giving various parameters and they are asking us for various parameters. Now let's see this. Okay, now main memory is 128 KB. Therefore what can you say about, I'm talking about the first question. Okay, main memory is 128 KB. First question, this is first one. Main memory is 128 KB. Therefore what is physical address? Physical address is 128 means 7 and 10, 17 bits. So this entire part put together is 17 bits. Okay, and then cache size is 16 KB and block size is 256 bytes. Since the block size is 256 bytes, then what can you say about the offset? Line offset or block offset is 256 means 8. Got it? So this part is 8. This total part put together is 17, right? And then we don't know about this lines, right? So how can we find out the number of lines? Line number, that depends on the number of lines, isn't it? So how many lines are in the cache block? So total cache sizes, so I want to find out the lines. Number of lines equal to total cache size divided by block size, right, or line size, both are same. Now what is it? It is 16 KB divided by 256 bytes. So what is 16? 16 is 2 power 14 divided by 256 is 2 power 8. Therefore it is how much? 2 power 6, right? So 2 power 6 lines are there. Therefore what will be the, how many bits are required to represent the line number? 6 bits. So 6 bits are used to represent the line number. And so what about the tag? So how many bits are required in the tag field? So totally it is 17 and 8 plus 6 is 14. Yes. Therefore what will be the size? The size of the tag is going to be oh, I'm thinking about something. 8 plus 6 is 14 and then 17, therefore it is going to be 3. So the number of bits required in the tag is 3. 3 bits are required in the tag. Okay, what is the meaning of this? Whenever you get 3 bits, it means that 2 power 3 main memory blocks are mapped to the one line of the cache. The ratio between main memory and the this cache lines is 2 power tag bits, right? So even you can see this is 128 KB and this is 16 KB. What is the ratio? 128 KB divided by 16 KB. Then how much do you get? So 128 KB is 2 power 17 divided by 2 power 14, which is 2 power 3, right? Okay, understood this? So it is nothing but these are the number 8 blocks of main memory are mapped to one line of cache. That is the meaning of it. So I don't want to confuse you by saying everything in the same question. That is why I have framed lots of questions. We shall go slowly. I think you understood this. You understood how to write it, right? So this is nothing but the line offset. And how did I get this line number? By finding out the number of lines in the cache. How do I find the number of lines in the cache? Cache size divided by block size. So I got 2 power 6 is the number of lines. The number of bits here is 6. Then since the entire part is 17, I have removed it, right? We can even simplify it. We would have solved it in a straightforward method, but we shall go slowly. Okay, don't worry about it. Now what about the size of the tag directory? Now watch it. Each tag information is going to be 3 bits. Then every line is going to contain tag, isn't it? See, in the cache, if there are these many lines, every line is going to contain the tag attached to this, right? Now each tag size is 3 bits. Then how many lines are there? 2 power 6 lines are there. Therefore, what is the size of the tag directory? 3 into 2 power 6 bits. 3 into 2 power 6 bits are there in the tag directory. That is the size of the tag directory. Okay, now let's solve the second question.